In this video I'm going to be reviewing projectile motion also. In this particular case the ball will be falling off of a cliff or a table, and it's going to have a horizontal velocity, so it's going to have a velocity in the x direction. It's not going to have an initial vertical velocity, so that initial vertical velocity will be 0. So I have a cliff, and the cliff is a certain distance above the ground. It's got a certain height. You can label the height h or y. And there's a ball that's traveling on this cliff. It's traveling with an initial velocity in the x direction. So in APC physics class I write down v naught x in honors and college prep physics class. For initial velocity in the x direction I just write down vi x. So it doesn't make a difference. Subscripts are just a little different, but the concept's still the same. So this ball is traveling towards the right horizontally. So it has an initial velocity in the x direction, but what it doesn't have is any vertical velocity because it's traveling horizontally. And this ball then reaches the end of the cliff and it flies off. It launches off from the edge of the cliff, and then somewhere a certain distance away from the cliff it's going to strike the ground. Now they're going to ask you quite a few different questions about the ball's motion. So this is projectile motion because at all points, once the ball launches off the cliff, it's traveling in the x and in the y direction. And at all points, it has this negative acceleration of gravity that's pushing it down of negative g, negative 9.8 meters per second squared or negative 10 meters per second squared. The one thing you want to remember is that when this ball starts flying through the air, it's going to start to develop a y velocity. So as it starts flying, initially its y velocity was 0, but then once it starts flying through the air, it's going to start developing a velocity in the y direction. And that velocity in the y direction is going to get stronger and stronger and stronger and faster and faster and faster because it's constantly being accelerated by the acceleration of gravity. Now the reason I'm putting the negative there is just to remind myself that this is a downwards velocity. It's moving downwards. And I'm using the scale that anything downwards is negative, everything upwards is positive. And everything to the right is positive, anything to the left is negative. So the first question they always ask you in problems like this is, how long did it take this ball to strike the ground? Well, from the first day of class, if you remember, the time it takes an object to go in this direction is the same as it takes another ball. Let's say I had another ball at this identical spot right here, and instead of launching it as a projectile, I just let it drop on its own. I just hold it and I just let it go. So when it falls, as it falls, the ball starts to develop a y velocity. And you're going to notice, just like from the first day of class we discussed, the y velocity is being created. It's getting stronger and stronger and faster because of the acceleration of gravity, and you're going to notice that both of these are going to have the same y velocity because both of them are falling from the same height, both of them are being accelerated by the same acceleration of gravity, and both of them had an initial velocity in the y direction of 0. So whenever you get a problem like this and somebody says, find me the time it takes this black sphere to hit the ground. Well, to do that, all you got to do is find the time for the blue sphere to hit the ground. And if you find the time it takes the blue sphere to hit the ground, this time is going to be the same as the time for the black sphere to hit the ground. Why is it easy to find the time for the blue sphere? Well, for the blue sphere, you know a few things. You know its initial velocity in the y direction, 0. You know it has an acceleration of negative 9.8 or negative 10 meters per second squared. You also know how high it's falling from. So there's this value that's been given to you. You just have to remind yourself that when you put in that number for y, it should be negative because it's downwards. The ball is being displaced downwards. So you can choose to make all of these negatives, or you can say, listen, I'm going to make it simple for myself, and because all of this motion is downwards, I'm just going to make life simple and say all the motion downwards is going to be classified as positive, all motion upwards is going to be classified as negative. If you went with that scale, that's fine, then all of these numbers will be positive. Choose whatever scale you want to use as long as you stay with that scale. So you have your final velocity, you have your acceleration, you have your displacement. If you want to find your time, you have a couple of options. You could just simply go into this equation, y is equals to initial velocity times time plus 1/2 at squared. You've seen this equation before, except you never had the subscript y in there. Now it's just reminding me that that's initial velocity in the y direction times time plus 1/2 at squared. That acceleration is your negative 10 meters per second squared. Now, this part of the equation is going to drop out because if your initial velocity is 0, 0 times t is 0, so your equation just simplifies to y equals 1/2 at squared. Well, now it's easy to solve because if you know what your y value is, your y value is some negative height, negative number for the height of the cliff, you know your acceleration is negative 9.8 or negative 10 meters per second squared, you can go ahead and solve for t. And that's easy to do because these negatives are going to cancel each other out and you'll be able to solve for t. And once you find your t, it's going to be exactly the same as the time for the black sphere hitting the ground. Finding the time is the most important part because once you find the time, the rest is easy to do. Because once you find the time, the next question they'll probably ask you, they'll say, how far does this black sphere, how far does the black sphere hit the ground from the edge of the cliff, from the bottom of the cliff? How far does it displace itself in the x direction? Well, then it's a simple projectile motion problem. You've got the time, you've got the x velocity, you know how fast this velocity is in the x direction because you've got to keep in mind that as this ball is flying through the air, it maintains the same initial x velocity. So the x velocity doesn't change. In collecting air resistance, there is no acceleration or deceleration on the x-axis. So the x velocity stays the same. That's why it can be labeled as an average velocity. So your average velocity in the x direction is the same as your initial velocity in the x direction. So if you know the average velocity in the x direction and you know the time to find this distance, this displacement in the x direction, you just go into your average velocity equation. Average velocity in the x direction is equals to displacement over time. What are you going to put for here? You're going to put in your initial velocity in the x direction because it never changed, so it's your average velocity in the x direction. What are you going to put in for your time? You're going to put in your time that you found for this blue sphere. Multiply the two, you got your displacement x. So that's how you find your time, and that's how you find how far the ball falls from the edge of the cliff. Now, the next thing they may ask you is that they may ask you, how fast is this black sphere's y velocity? They've given you the x velocity, they gave you a number for it. So they may ask you, what's the black sphere's y velocity? Well, that's also an easy problem to do because you'll notice that you can draw some comparisons with the blue sphere. The black sphere and the blue sphere have the same y velocity. So why not go back and solve for the blue sphere by saying, look, I know the blue sphere's initial y velocity is 0. I know the blue sphere is falling with an acceleration of negative 9.8 meters per second squared. I know the blue sphere's displacement is this y value, it's some negative y value. And you're going to put in a number for whatever the height is. And you can solve for the final y for the blue sphere, which will be the same as the final y for the black sphere. And you can solve for it using your equation v squared is equals to v naught squared plus 2ay. You can solve for it because you know your initial velocity is 0, you got that variable covered, you got your acceleration is negative 9.8, you got your displacement, the height of the cliff, negative whatever height the cliff is. You multiply 2 times a times y, take the square root, and you've got your velocity in the y direction for the blue sphere. Check, I'm placing a check next to it saying that you can solve this. If you know the y velocity of the blue sphere, you figured out the y velocity of the black sphere. That's how you find out the black sphere's y velocity. Finally, they may take it a step further. And they may say, now that you have the black sphere's x velocity and y velocity, tell me what is the true velocity it is traveling at? What is the ball's final velocity it is traveling at, the net velocity? Well, that's an easy problem to do because if you have the x component and the y component, you're going to use Pythagorean theorem. You can move this side of the vector, this vector, over here so that the black and the brown vectors are touching head to tail. And if you move it here, you've got a right triangle, so you do a squared plus b squared, and you can solve for c squared. So you're going to solve for your v velocity, your velocity, the net velocity of the black sphere. So comment, just regular trig will help you over there. And then if you want to use your trig functions, you can also find the theta, the angle with which the ball hits the ground. You can find the angle with the horizontal, or you can find the angle with the vertical with which the ball hits the ground. You can use inverse sine, inverse cosine, inverse tangent. Now that you have two sides of the triangle, you have the v naught x because they gave it to you in the problem. You have the v naught x, and you solve for the vy. You can do Pythagorean theorem and find the green side. So now when you have three sides, you can use inverse sine, inverse cosine, or inverse tangent to find the theta. Hope you found this video helpful, and I will review some of these concepts in class also.